Welcome to lesson 51. You've been doing a great job with one-step equations. Now we're going to do two-step equations, which are typically in this form. Ax plus b equals c. That's what they simplify out to. So while I'm modeling, you're going to look for how I write the equation in that form, how I turn that constant number, that b, into a zero using an inverse operation. I'm going to make some zero pairs, and then I'm going to isolate that variable using an inverse operation. And in most cases, it's going to be division. And you're going to look to see how I always consistently check my work using substitution and the original equation. So far, we've talked a lot about one-step equations, and they've been in two forms. Ax equals c, where a is our coefficient. And we know to solve this, we're dividing by a. So this is kind of the work that we've been doing. When ax equals c, we're dividing both expressions by a, so we get x is equal to whatever our other expression is divided by a. The second form we have is x plus b equals c, where b is our constant, and we've been creating zero pairs by, as if b is a positive number, we're subtracting b from both sides, so x is equal to c minus b, or if b is a negative number, we're adding b to both sides, still a zero pair, and x is equal to c plus b. This is what we've been doing so far, but today we're going to start looking at two-step equations. So I'm going to just try this out without numbers, and we're going to talk about how we're combining some steps. This form looks like this. What if we have a coefficient, ax, and a constant b equal to another number? So now we have two things to do in this type of problem. So guess what? We actually already know the two things that we have to do. It's just we're not used to doing both of them in the same problem. The first thing we're going to do is we're going to deal with this b. So here's our first part. We have to eliminate that b first. And we know how to do that. When we have a constant, we know we're getting rid of it with a zero pair. So we know that happens. So ax is equal to c minus b, whatever that answer is. And then we know how to deal with this ax. We know we're just going to end up dividing by a. So we're left with 1x. We're going to do the same thing to the other side. So this looks really complicated, but what I really want you to focus on are these steps that we know how to do. That one, we know how to deal with that constant first by creating a zero pair. And then we know how to deal with the coefficient next using division. So it's the same two steps that we've already been doing this entire time. We know how to deal with constants, and we know how to deal with coefficients. All right, so let's hit pause. This is going to seem way up in the air. This is a big picture, but we're going to try this with some real problems, and you'll see how it works out with the numbers. Kelly has $23 saved for a new pair of sneakers. She gets $15 allowance every week. She uses $7 to buy candy, and she saves the rest. If she now has $135, how many weeks, W, that's our variable, did she save her money? Create an equation and solve for the number of weeks W Kelly saved her allowance. So basically we need to create an equation for this scenario and then use it to calculate how many weeks she saved her money to get the sneakers. Here's what we know. We know she started with $23. We know she gets $15 a week, but she spends $7 and saves the rest. So automatically, since I know that's every week, that's telling me that this is a rate. We know in all she ended up saving $135, and the number of weeks is our variable. So here's our plan. I'm going to line it up and then act it out. I'm going to write an equation that represents the scenario in ax plus b equals c form. Look to see how we solve for the unknown, and I isolate that variable. I'm going to start by creating that zero pair, and then I'm going to divide by a to isolate the variable. And finally, I'm going to check work by substituting the answer. Hit pause so you can jot down this plan in your notes. Let's start off with our visual because we have tons of facts here. We want to make sure we have the right story. So we know she starts off, Kelly has $23, and each week she gets $15 every week, but she's also spending $7 on candy, and she saves the rest. So that's going to be an important distinction. So how much does she really have every single week? If she has $15, she keeps spending $7, that means she's going to save $8 every single week. And that's going to be important for us. And we want to know how many weeks does this happen until she gets enough money for her sneakers, until she has $135. All right, so that clarity is really helpful to me because now I can write this as an expression. She starts with the $23 and she's saving $8 a week. Why? Because she gets $15 for allowance, she spends some, spends $7, and she's left with $8. And we want to know how many weeks it will take to get to $135. Earlier we talked about how to solve these types of two-step problems. Matter of fact, I'm going to put it in the same form. We said AX plus B equals C. So let's put it in that same form. 8 a week, plus $23. How many weeks will she have to save to get to $135? We're going to start with this one over here, a constant. Let's turn this into a zero pair. That's always going to be the first step, is to deal with this constant and to create a zero pair out of it. So I have positive 23, so I'm going to use this opposite, negative 23. I'm going to subtract 23 for both sides. That way, I'm only left with 8W. Okay, this cancels out. And on the other side, we're going to subtract, and we're left with 112. If you're already starting to feel worried or less confident, fine, you have your calculator, you can double check. I have 112. That sometimes happens when we're learning something new. We start to doubt ourselves in other little ways. So you got this, you take it piece by piece, confirm with your calculator. Now, we know how to solve this one-step equation. We have a coefficient here, so we're going to divide both expressions by 8. So we're left with only W weeks. All right? So now we have 112 divided by 8. I'm going to do that here on the side. 112 divided by 8. One time makes 32, and 8 times 4 makes 32. Okay, so W is equal to 14 weeks. Again, you can, if you're really unsure and you want to check your thinking, you can just use your calculator, you get 14 weeks. Perfect. Let's check our work. Always really helpful, because when we're doing this, we're going to have an answer, but we want to make sure we have the correct answer here. So here's our original equation. 8W plus 23 is 135. Let's substitute. 8 times 14 plus 23 is 135. And now we got to use our order of operations. We're going to do our multiplying first. 8 times 14 is equal to 112. 112 plus 23 is 135. That 112 plus 23 is 135. So we are correct. 135 is equal to 135. We are correct. So let's make sure we restate our question. Create an equation and solve for the number of weeks Kelly saved her allowance. Kelly saved her allowance for 14 weeks to buy sneakers. And all this is verified in our work. Hit pause so you can jot this down. You guys are getting this. So let's do a little bit more practice so it becomes more familiar. So here's our form, AX, so we have a coefficient plus a constant is equal to another number. 4h is our coefficient plus 32 equals 60. We're going to deal always with our constant first. We're going to create that zero pair. So let's subtract 32 from both sides. That makes this into a 0. And on this side, that in there, we have 28. So now we have 4h is equal to 28. That's simpler. And for a lot of us, it's just making our eye look only at this part now. Now it's a one-step equation. So how do we isolate to get the h? We're going to divide both sides by 4. And h is equal to 7. Let's check our work. And we have 4h plus 32 equals 60. So 4 times 7 plus 32 equals 60. Order of operations, we're going to do the multiplication first. 28 plus 32 equals 60. And yes, 28 plus 32 is 60. There you go, in case you want to see it on our calculator. It is 60. 60 equals 60, so we are correct. Hey, pause so you can jot this down. And this is really helpful, right? We're getting our two steps. We know when to see which ones we're doing first. Always the constant first. And then we deal with that coefficient and we can get a final answer and check. We'll do another one. And notice here, this one is not written in that same form we're used to seeing. But that's okay. What I tell a lot of kids is if you want to, you can put this into AX plus B equals C form. If that's helpful for you, do that. And just recognize, where do we have the coefficient and a constant? I have them right here. So negative 6h minus 2 equals negative 8. So if that's helpful for you, rewrite it into that form. It'll be fine. Now we're going to deal with our constant first. So at negative 2. How do we turn negative 2 into a 0? By adding 2. We're going to add 2 to the other side. So let's see. I owe $8. I get $2. So now I'm at negative 6. Okay, so negative 6h is equal to negative 6. We're going to divide by our coefficient, negative 6 and negative 6. So h is equal to positive 1. Let's check our work. Negative 6h minus 2 equals negative 8. Negative 6 times 1 minus 2 equals negative 8. A negative 6 times a positive 1 is still negative 6. So negative 6 minus 2 equals negative 8. And yes, just thinking about this, if I owe $2 and I owe another $2, I now owe $8. So negative 8 is equal to negative 8. If you want to check that, you're unsure, you're not as confident, you can check it with your calculator. It is negative 8. So there we go. So you can jot this one down into your notes. So notice for this one, I did rewrite it into form. And if you're curious, well, what if you didn't want to rewrite it? Would it still work? Let's say you kept it into the same form. You're still going to do the same thing because I still need to add 2 here. Doesn't matter, it's on the right side. The math doesn't change. So I still have negative 6 is equal to negative 6h. And you're still going to divide by negative 6 to get 1. So if you find that this form helps you to see what to do, fine, rewrite it. Just make sure you're just using the terms that are there and looking carefully. But you don't have to do the work. You just have to be able to recognize which is constant and which is the coefficient. So that's it for practice today. Hit pause, jot this down, and I will see you in the next lesson. Get tons of practice in Math Marbles.